Welcome to the session on solving trig equations. Now, let me just tell you that I'm assuming we're solving now some complex trigonometric equations. And you may want to, if you haven't already, take a look at first solving basic trig equations, that session, and then go to another session, finding the other trig solution, that's another session, and finally another session expressing infinite solutions for trig equations. Those are three sessions you probably want to look at if this is new to you. So this is going to kind of gloss over those details, assuming you already know them. So if you don't know, if you find yourself getting confused or just don't have all these details, go back to those three sessions before you keep going on here. So we will start with the process. First of all, always be in radian mode when you're solving trig equations. You'll see why really in step 4 where you resubstitute. But here's what I do. First I do a substitution, and that's of course only necessary if you have anything other than a simple angle. Then you do the algebra, if there is any, to solve for the trig function. That's to isolate the trig function. And at this point, in step 3, you should have a basic trig equation. Now essentially everything we do is to reduce everything down to a basic trig equation. That's how we really solve. And then you go through the 3 steps, find the calculator solution, find the other solution, find infinite solutions. And once you've got the infinite solutions in terms of your angle, now you go back and resubstitute from what you did in step 1, and finally solve for the original variable. So let's take a look at an example. Negative 3 cosine of 2x minus 1 plus 5 equals 7. Alright, so this is definitely not a simple angle. This is, the argument is complex. It's got 2x minus 1. Your angle's x, but, it's got all this stuff. For it to be simple, you should have just had cosine x, not 2x minus 1. So the first thing we're going to do is a substitution. And in that case, I'm going to say let theta be 2x minus 1. And so that way, when you rewrite this, you're going to have negative 3 cosine of theta plus 5 equals 7. So now that's what I call a simple angle. And here you're ready to do the algebra. To solve for cosine theta. So what I want to do is subtract 5 from both sides here. So I have negative 3 cosine of theta equals 2. And now I want to divide by negative 3. And that'll leave me with cosine of theta equals 2/3. And, oh, I'm sorry, negative 2/3 because that's a negative 3. Okay, there we go. So cosine of theta equals negative 2/3. Now I'm at basically step 3 where I have a basic trig equation. So that's kind of nice. Let's go ahead and find our calculator solution. So here we're at step 3. We're at a basic trig equation with cosine theta equal to negative 2/3. That's what we're solving. So theta equals the inverse cosine of negative 2/3. And so to find the calculator solution, you just plug that into your calculator and it'll give you theta equals 2.3005. When you go to find your other solution, then remember you're really looking for where the calculator gave you that first angle where the x coordinate is negative 2/3, so that's maybe over here. And so that's 2.3005. That's your calculator solution. Now you got to find the other solution over here. And so that's going to be, if this was the calculator solution, this is going to be your other solution. So it's negative 2.3005. And so now infinite solutions. Well, these are not equidistant apart, that's for sure, so you're going to want to have two separate generators. Where k is understood to be an integer. And now, this is probably the step where it's so easy to forget. That's why I have it as a separate step. Resubstitute. So you let theta be 2x minus 1. So now, in the place of theta, you're going to have 2x minus 1 equals 2.3005 plus 2k pi. And you're going to have 2x minus 1 equals negative 2.3005 plus 2k pi. Okay? So now let me rewrite that. And I've now got to solve for x, the original variable. Okay. So we have 2x minus 1 equals 2.3005 plus 2k pi. And so here you're going to add 1 to both sides. Get 2x equals 3.3005 plus 2k pi. And now you just divide by 2. Remember, every term gets divided by 2. So you have x equals 1.6503 plus k pi. And now your other resubstitution, you add 1 also. Okay, and then divide by 2. Every term gets divided, so x equals negative 0.6503 plus k pi. Alright, so those essentially are your generators. Okay, and we're done solving. Again, I just want to show you that if you want to find specific solutions, you just basically put in different values, integer values of k. So we'll just continue on here. For here, if k is 0, obviously you're going to get x equals 1.6503. If k equals 1, you're going to get x equals 4.7919. K equals negative 1, you're going to get x equals negative 1.4913, and so on and so forth. And again, I'll just check one of these so you could see. Check the first solution on this. Your check would be to resubstitute your specific solution into your equation in the place of x and see if you get a true statement. So you'd have negative 3 cosine of 2 times 1.6503 minus 1 plus 5. Is that indeed 7? And I get 7.000169973. I think that's pretty good. So again, you can do this for each of these specific solutions and prove to yourself that, wow, okay, this really does work. I've got the right solutions. I found that to get the kind of accuracy you need to really recognize that you're getting the right answer, you have to go out about 4 decimal places. Going out less, you could actually have solved the equation correctly, but you can actually be far off enough when you plug it in that you can't tell. So I would go out 4 decimal places. Okay, we'll do a few specific solutions here. And we'll do these substitutions. So x equals negative 0.6503, k equals 1, x is 2.4913, and if k equals negative 1, I get x equals negative 3.7919. Again, these are just integer values I picked. You could have picked any integer value you want. Okay, so that's our first example. Now let's go ahead and look at our second example. And that's going to be 6 minus 14 sine of 3 pi x minus 4 equals 9. That looks nasty enough, doesn't it? Alright, so number 1, substitution. Alright, so obviously you've got a very complex argument. The argument is what's coming into the sign. The argument is 3 pi x minus 4. You really need it to be simple. So we're going to say let theta equal 3 pi x minus 4. So then, in part 2, you're solving for the trig equation, or the trig function. So you have 6 minus 14 sine, now it's just theta because of your substitution, equals 9. And that's a lot easier to handle. So now we're going to solve for the trig function itself, which is just the sine theta. So we're going to have to subtract 6 from both sides. We get negative 14 sine theta equals 3. Now divide by negative 14. You'll get sine of theta equals, oops, did it again, negative 3/14. Alright, so now you're here. This is a basic trig equation. So now you want to work with your basic trig equation. We now have a basic trig equation. And the first part you want to do then is find calculator solution. Okay? So, when I go to solve for that, theta is the inverse sine of negative 3/14, for which the calculator will tell me, theta is negative 0.2160. So then, we want to go and find the other solution. So the other solution is, again, you're looking for where the y-coordinate is a length of negative 3/14. So let's just say here. And so this would be, this y would be negative 3/14. So the rotation itself, though, is negative 0.2160. This was the calculator solution. So you know you've got another solution over here that you've got to name. And that's going to be pi plus 0.2160. Remember, this is the case where you have to work with the reference angle and make that reference angle positive, because you want pi plus the 0.2160. Gives you 3.3576. Obviously, these are not equidistant apart, so when you go to find the infinite solutions, you're going to have separate generators for each one. Theta equal negative 0.2160 plus 2k pi. And theta equals 3.3576 plus 2k pi. Finally, step 4, well, not finally, but this is a real important step. Remember, it's the one I even write with an exclamation point. So you're going to have 3 pi x minus 4 equals negative 0.2160 plus 2k pi, and 3 pi x minus 4 equal to 3.3576 plus 2k pi. Now you're going to solve for x, for the original variable. So, 3 pi x minus 4 set equal to negative 0.2160 plus 2k pi. We're going to add 4. We have 3 pi x equals 3.784 plus 2k pi. Divide by 3 pi. Every term gets divided. And you'll arrive at x equal to 0.4015 plus 2/3 k. That's for the first generator. Second generator, 3 pi x minus 4 equals 3.3576 576 plus 2k pi. You add 4. You get 3 pi x equals 7.3576 plus 2k pi. And now divide by 3 pi. And you get x equal to 0.7807 plus 2/3 k. And that's it. So, those are our two generators. Again, if you want specific solutions, just substitute values, integer values for k, and you'll have all the solutions you want. Thank you so much for listening.